domain of my thesis is portable and scalable applications for the like the facility management. As far most of the buildings, they have HVAC systems that are used to keep the indoor like environment in a to be good for the people who work inside. So it is like the basic schema of the HVAC system. We can see here air handling unit that is a blue one, and like the red ones, it is zones that it serves basically. And most like interesting thing here, it is sensors that are pointed as S in the air handling unit. Those sensors, they usually have very long tags, and these tags, they are usually specific from one building to another. And it is actually a big problem if you want to develop an application that could be scaled and work not only on the data from the one building, but also scaled for like a number of buildings. So to overcome this problem, we can use a thing that is called ontology. In my case, I used a brick ontology that is open source, and of course, it is free to use for everyone. And here you can see basically the same schema, also HVAC system. And here it's like a representation, but in the ontology. Here we can see, for example, same sensors, but it has like a specific path. So a little bit more about Brick. Here is the Brick official website. It is based on the 5 basic classes that are used to inherit from the like smaller ones. For example, here is an example of air handling unit. Here we can see like a simple like how to say description of it, and also classes that are inherit from this big class. And this ontology can be also thought as a big source of data, or like just Lego puzzles that can be used to describe a real facility. And when we are like using it, we store them in a specific way. This way is called an RDF schema. In RDF schema, we have basically subject and object that have a specific like a connection. It is called like a predicate. And after it is structured as a single model, it can be used as a source of data to extract the specific data that we need to develop a specific application. To extract all the data, we use a Sparkle. It is something similar to the like an SQL, and I will show how it is like decomposed after. Yeah. So here it is. At first, we have to mention all the prefixes. Those prefixes, they were actually like mentioned on the Brick website. It's basically like the link that makes some entity like unique to be more like clear when we are trying to make this ontology model. Then we have a select line that is basically like an SQL, then from named, and all those like SQL things. Yeah, and for example, here we have like an example how it can be used. So, for example, here we have a Brick representation of this part of the air handling unit. We have an airflow sensor, damper, valve, and the temperature sensor. So, for example, if we want to make sure that we have some faults there or something works not correctly, we can develop a specific like a query that will be the same for like every sensor and air handling unit. Yeah, and after it can be executed on the single model, and after it can be scaled to the another like buildings that are also encoded in Brick that have a Brick like a representation. It makes us to outcome that barrier with those long sensor tags that are like different from one building to another. So since we will have a specific like a defined structure. And to prove it that it is actually possible, I developed a simple application. Application utilizes a brick model. I will show you how I did that later. I use a thermal database just to have some like a temperature value to compare with. And I use an IFC as a source of the location data, since we have a different climate like everywhere, and we have to know a specific location of the facility. But it is also actually possible to define it manually. Yeah, and the purpose of this application is to build a simple heat map that will show us is everything going good, or maybe we have it hot than we want it to be or less. So I will show you how I did that. All the tools that were used for this application, they are open source. So you don't have to pay like anything to Autodesk or anybody else. It can be done by everyone if you have just some basic skills of the programming. So it is how I developed the brick model. I used the RDFlib Python package, and basically I just did the namespace. Then I added one triple by another, like step by step. So second picture, like in the middle, it is just the building, and after I create like the connection that for example, Be My Room is the part of that building. And all the classes and all the like relations that I use, they are from the Brick Ontology website that I showed you a few slides ago. After I had this simple model of the building, as you can see, it is just one building. It has 2 rooms. It has one air handling unit, 2 VAVs, 2 zones, and 2 sensors. Yeah. As for sensors, I use the specific class from Brick. It is has time series reference, like a relation to link the path to the database that will write the data that is produced by sensor. So in my case, it is just a path on the local host, on the local thing, and after it was serialized into the specific format. In my case, it was a turtle one. Here you can see how it looks like. It looks a bit complicated, but here you can actually see all the same things. Here is the air handling unit, sensors, and all their like connections that they are used in. After I have the brick model, I can apply specific data, like how to say, to extract specific data that I need for my application. In my case, I just need a sensor and data that is produced by sensor, like path to the database. As I told, I use the specific relation. It is a has time series reference, and after I just put it into this query, and after I was able to have sensors and the data that it was like produced by it. Yeah, data from sensor is basically just a temperature, and that temperature was compared to the specific value from the comfort database, and after it will be shown on the heat map. Yeah, and as far for the IFC, I used an IFC OpenShell just to extract the location from the IFC site class, and here you can see the simple script of that. Yeah, as for the front end, I use the Streamlit Python package. It is a open source also package that can be used for free, that is used to develop data science apps. Here is a simple front end. Here you can see that you can upload a brick model, also an IFC, and select location of the building like manually, or it will be extracted from the IFC if you upload it there. After you can get this heat map. If it is yellow, it's okay. It is like in the comfort range. If it is blue, it's much lower. If it is red, it is higher. And that application, it was put into Docker, actually. Docker, it is the thing that allows you to run your application in a specific, like a container, and it can be exchanged among users. It is one of the advantages of using Docker, and also it can be easily like modified. I mean, the application in general. Since I didn't have any real data, I had to just randomize data. But for example, if we have a specific server with the sensors that write data using some building management system protocol like BACnet or something else, it can be just put into the second, like a container. And if something changed, we can just change that container to another one. And this makes this application like decentralized and flexible. Yeah, here is actually like an example how it can be used. So we just have basically two containers that can connect with the IP protocol, and we use a Docker Compose tool to actually start those containers and to work in the like a synergy. Yeah, and after as the workflow, when we have the application done, we can test the scalability. To do this, we can use the software that was developed by the Brick team. It is a Mortar. It is just a big database that already stores data about like the buildings and sensors. And this application just can be tested on these things, on this thing. Yeah, so thank you for your